Okay, I think we are live. So welcome. Today, my name is Sara Pulido. I work for Datadog, and I've been doing a little bit of these live streams to learn things that you can do with Kubernetes and Datadog. And today, what I had planned was to have a look to a thing called Firekube by Weaveworks. It's an open source project, and it says that it's an open source Kubernetes distribution that enables secure clouds anywhere. But actually, when you look a little bit further on what exactly it is, for me, it seems that it's a way to spin up quickly a Kubernetes cluster that it's GitOps ready. So Weaveworks have been promoting a lot the concept of GitOps, and many of their tools are around this topic. They have quite a big guide of what GitOps is for them. You can basically browse around and read all the information that they have. But very high level, what the GitOps is that extending the concept of infrastructure as code to anything that is running on your infrastructure. Not only the infrastructure itself, like things like Terraform, but anything that you run also on your infrastructure. So all your configuration, all your applications, all of that is going to be always the configuration is going to be in Git. Git is going to be like the source of truth, and all your operations are going to be based on what is on your Git repo. So very high level, this is what it is. And they have several open source tools that are trying to implement this concept. So this is more or less what Firekube is. This is a Kubernetes cluster that is ready for this GitOps kind of way of doing things. So let's try to create one and see what it is. So looking at the repo that they have, it seems that what Firekube is really a set of a wrapper for many tools that they already have. So we will have a little bit a look to this setup.sh, but it's basically a bash wrapper that uses several tools. What it's going to do, it says that it's going to create a cluster using Ignite, which is a tool that they have to create a spin-up VMs, and Firecracker, so these AWS small VMs, micro VMs. Obviously, so right now I'm not running on Linux, and therefore I cannot use KVM or any KVM-related technology. But they say that if you run macOS, which is my case, they basically move to use another tool that they have called Footloose, that is basically Docker containers that have some structure as a VM. So basically, Docker containers that has systemd as process ID number one, and then it feels like a VM, but it's just a Docker container. So in our case, if we are running this on macOS, it means that we are going to be running probably something like Docker in Docker. Okay, so the first thing that they say is that fork this repo. So let's do that. Let's fork the repo. And the reason why the first thing is to fork the repo is because, again, this is a GitOps ready Kubernetes repo, Kubernetes cluster, and therefore we need a repo to hold everything. So to have all the information about our cluster, all the information about our applications. So this is the first thing that they say, and then you have to clone it. So let's do that. Let's do the same thing that they say. So my GitHub user is this one. And now we have to clone the repo. Okay, we have cloned the repo, and the next thing it says is that setup.sh. That's the only thing. Before we're doing that, let's have a quick look to this. Hopefully it's big enough. So we have here a configuration that it's specific to Firekube. And it says the backend is Ignite, that we already said that we were not going to be able to use. But it says that it's going to do everything for me, so I won't change anything. And as I said, it has basically a bash wrapper of using several tools. So let's run the setup. Okay, so it seems that the first thing that it has done is to fall back to Footloose instead of using Ignite and Firecracker. So it seems that they're doing okay. It basically created a couple of machines. So node 0, node 1. This is the Docker image that it's using. Okay, so this is going to take a while. So while this is running, and I don't create enough of this, let's make this bigger. Okay, so this has created a couple of containers. So this is 2 containers. The node 0 that we saw and node 1. I guess if we can kind of mimic SSHing into this container, you can see what's going on. Right now it's setting it up, so it's creating a Docker bridge, and it's creating some interfaces. This is still initializing, so this is going to take a while. So while this is running, let's have a look to some of the tools that it's going to use. So one of the tools that it's going to use is WKSCTL. I don't know how they pronounce this. Probably they have a canonical pronunciation for this. That is not the one that I'm using. And basically what it does this is to be able to configure your cluster in a declarative way. If we look to if we refresh our repo and see what's going on here, we can see that automatically it has already created 1 commit. And basically what it's going to do with that commit is adding into my Git repo my real configuration. So if we open this one, we can see that it's Docker, it's not using Ignite anymore. And if we, for example, open the machines, it will say the different machines that are part of my cluster. It's using this this API in Kubernetes to define clusters. So this is official Kubernetes API. What else? It has here this hasn't changed apparently. So it doesn't have any configuration there for us. Okay, let's see how this is going. Okay, it seems that it finished. So let's do this. So it has created a kube config for us, which is good. It's always handy. So we don't have to create one of those or even look for it, because at the end of the script, it already says. I have aliased K to kubectl, so I don't type that much. So whenever I type K, is kubectl or kubecontrol or kubectl, whatever you call it. So it only has one node, and we know for sure that it has created two of those machines. So probably what it's happening is that it hasn't finished. So this uses kubeadm to create the cluster. So probably it's still doing some things on the second machine to join that cluster, that first cluster. Let's see how this is evolving as well. So this is the first node. This is the control plane node. Let's clear this a little bit. Okay, so this is looking a little bit more complete now. So not only it has the Docker bridge, it has some external interface, and it's using WIF as CNI, so as the container networking interface, which makes total sense because this tool is made by WIFWorks, and WIF, the CNI called WIF, is also made by them. So it makes sense that they're using their own stuff. Okay, let's see how this is going. It's still just one node, so we will need to wait a little bit more so we can continue seeing this. So as I said, this is the first tool that they use. This tool is to create clusters in a declarative way. So to define a cluster and then having some controller, some machines, something that creates the cluster for you. And the other thing that they use for this GitOps thing is Flux. There is basically a controller that it's going to take the Git repo that we have with all our applications, and it's going to deploy that into our cluster. So that's the second thing that they use. Since August 2019, it's a CNCF sandbox project. Good to know. And they also use this JK, that is basically a tool to create a templating tool for configuration files that is using JavaScript. So I've never used JK, but if you're a JavaScript developer and you want to do this transformation of YAML files and config files, it might be a good solution. Cool. Let's see if it finishes at some point. Yeah, we have 2 nodes. This is good. Let's see that again. Okay, sounds good. Let's see all the pods that we have right now. Okay, so we have 2 namespaces, kube system for all these things that usually we have in any control plane, like scheduler, etcd, core DNS, the API server, etc., etc. And we also have a second one, which is called with Kubernetes operations, that has, I guess, everything that they put on top for this GitOps workflow. And they have WIF, and they have Flux, as we said. We have this WKS controller, which I guess is to make any changes to the cluster itself. So we all have that. And actually, if we see, if we do wide to know which node are those deployed to, it looks like everything that is specific to the control plane except obviously the things that needs to be like kube proxy and WIF that has to be on every node. Everything is deployed to node 0 and nothing is deployed to node 1, which tells me that, they have put some taints on node 0 on the control plane by default. So only the control plane pods go there. Let's check that. Describing our node 0, we see all the different pods that we have created. And yeah, it has the classic taint of no schedule because I'm the master. I'm a master node. If you need to deploy anything on this node, you will have to put the same taints on your pod descriptions. Okay, cool. So we have our cluster now ready. So what I'm going to do is I'm going to deploy a small e-commerce application that I have. And instead of doing kubectl apply and apply my manifest, what I'm going to do, I have them here ready. I'm going to copy them into the folder that has my Git repo. If I do that recursively, that's going to work better. So now I have my e-commerce app folder here. Let's clean this a little bit. If I do git status, it's going to say, okay, you have a new thing. You can see that it has several manifests. So it has a DB, some front end, some regular traffic to fake some traffic into the application. If we have a look to some of those, just for example, this is an example, you can see that basically it's just a deployment and a service. So how do we deploy that in a GitOps environment? So we have to add it to our Git repo. So let's do that. Let's do our commit. So e-commerce app. And obviously we have to push that to our repo, to our remote. So the magic happens. So if we start watching what's happening on our repo, so start getting the pods, we should at some point start seeing something here. And we don't see anything yet. Okay, let's see what's going on. No pods. I have pushed this to my GitHub repo. No, we are here. I was just being impatient. So you can see here that it's creating the containers. I didn't have to add kubectl apply. I just needed to push it to the Git repo. And the good thing about this is that I can make sure that everything that it's happening on that repo, on my cluster, is already on the repo. So I only have one source of truth. Hopefully this is it's going a little bit slow. But yeah, some of them are already running. Let's see. While this is creating, let's see how this happened. So let's clean this a little bit. So we have this namespace with all the WIF projects are being deployed. And we have this one Flux that we mentioned that was the one that the controller that will reconcile everything. So let's see the logs on that one. I have to say that the name of the namespace is a little bit tricky. So you can see that basically this is just a loop that is checking on my repo for changes. That's the only thing that it does. And when it finds a change that it's related to something that I wanted to deploy on my cluster, it's going to basically kubectl apply those changes. So this is pretty straightforward how it works. Still creating the container. While this continues creating, what I'm going to do is I'm going to deploy Datadog as well, the Datadog agent, so we can see how it looks like from if I want to monitor this cluster, which is a little bit not unusual cluster in this case because it's Docker in Docker. So the first thing that I'm going to do, and this is basically the only thing that is not going to go to Git. The one thing that you should never have in a Git repo are secrets. And if you want to have a full GitOps loop or infrastructure as code, whatever you want to call it, you have to have some solution for your secrets that doesn't imply having the secrets. Some of those solutions are, for example, Vault. There is another tool that is recommended by Weave itself, Weaveworks, which is SIL Secrets, which is an open source tool created by Bitnami. That basically what it does is you only put in your Git repo an encrypted secret, and the only way to disencrypt that secret, it's your cluster through a controller. We can talk about it in a different live stream, but the thing is that if you have a secret that is not encrypted, don't put it on Git. So I'm going to do this in a different window so you don't see my secret. Again, this is a demo account of Datadog, so it shouldn't be too much of a problem, but it's better to be clean. Let's see how this is going now that okay, all of it's running. Let's have a look to our app. Let's see if we can do things in this Docker in Docker environment. If we can do things like port forward. My app is listening on port 3000. So let's see if we can have a look to our app. Okay, this is our app, so we can do port forward as well. So this is very cool. One of the things that we didn't mention when we were looking at our notes is that we are running version 1.14 of Kubernetes, which seems to be a little bit old already. I don't know if this is because Weaveworks is not maintaining a lot Firekube. As I said, Firekube is just like a wrapper of all these tools, and maybe the tools themselves are being maintained, but Firekube itself something to take into account. Okay, so let's copy Datadog into our Git repo. Same thing. So I have some manifests ready here. We have service account and some permissions, some cluster roles and cluster role bindings, and the Datadog agent. We just created a secret without having on anywhere in Git. So if we want to do this real GitOps, we would need to use again something like Vault or SIL secrets. If we do a Git status again, we have to do this the GitOps way. So add Datadog monitoring. And then we need to push that to GitHub. And hopefully at some point we will start seeing Datadog being created. I don't know if I guess Flux allows you to reduce the number of seconds or the lapse that happens between every check to Git, to the remote, because it feels like it takes a little while. Okay, the container is creating, which is good. It means that we have all the configuration that we require. For example, the secret is already there. Let's watch this for a while. One of the things that, while this is starting, when I was reading a little bit about in this guide to GitOps, again, this is Weaveworks' view on this topic. They have been promoting it a lot, but it's just their view. They make the distinction between infrastructure as code and GitOps. And the difference that they say is that infrastructure as code has been around for a while. It allows you to have your infrastructure like your DNS records, your EC2 machines, or your VMs, everything as code in Git. And this extended to anything else, like everything that you are going to ever deploy in an infrastructure, either the infrastructure itself or everything else is going to be in Git. So it's more or less the same concept, but it's a little bit more inclusive. Okay, hopefully this is running. Oh, it's running. Let's have a look let's run the command that gives us the status of the Datadog agent, so we know whether it's doing something useful. So it looks good. It has all the different logs here, all the different checks as well, including the Kubernetes specific checks, the Docker checks. So it's going to have some views on the containers that we are running in this Docker cluster. So let's have a look. The application that we have deployed is already instrumented for APM. So we already can see things like the number of requests that we are getting on all of these services, which is very good. We can see how our application looks like. What else? Do we get the node? So it says no host reporting yet, which is weird. Let's have a look to containers. Probably it's just started collecting information. It's going to take a while. So it's showing all the containers. So we should have already the information. And actually we do. I don't know what's going on there. It says that it comes from host node 1. Let's see the host dashboard. Cool. So it seems that we're already having some data from the node. Again, something that we can mention here. The Datadog agent is deployed as a daemon set. That means it's going to get 1 pod per node. And we have 2 nodes, and we only got 1. Why? Again, same thing. It's because of the taints on the control plane. If you want to also have a look to your control plane, you will need to modify slightly your manifest to do that. That's why we only show 1 node instead of 2. So we have container information, we have processes. So we can see all the processes that I'm running. We have a Puma, because it's a Rails application. We have the agent running here. All the processes inside all of our containers are going to be shown here, which is pretty useful. Again, right now we are only seeing visibility of node 1. If we want to have visibility on node 0 as well, we will need to modify. So we put an agent in that node. We also have access to all the logs for any container that we have. So it's pretty interesting that we know this is Docker in Docker, and yet we are able to see as if it was a real VM, a real cluster, which is pretty interesting. Cool. So I think this is a good enough for an intro to Firekube. Again, it seems to be, I would like to ask the people at WIF if they happen to see the recording, if they're planning to update this. So right now it's, again, 1.14, which is pretty, well, it's not super outdated, but it's quite outdated. But this seems to be an easy way to spin up a cluster. Again, if you're using Linux natively, you can use also with KVM and Firecracker, which probably is more interesting than this example. But it's a good way to spin up a cluster if you want to start playing around with this GitOps concept. So if you are interested in learning about GitOps, what it entitles, what it means for you, it could be a good way to see these things. And again, as any Kubernetes cluster, you're going to have all the information available in Datadog. You can have all the information about the pods that you're running, the kubelets that are running, number of containers, etc. You have all that information, just because Kubernetes is Kubernetes, no matter how do you deploy it. I hope this is useful. If I'll try to do a follow-up with if we ever get a reply from WIF about updates. And again, thanks for watching.